Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Your task for today is to do question 4 onwards until it finishes, which is question 7. So I'm going to give you some hints and some guidance because I found that some of the questions were missing. I don't know if it appears like that on your paper. Okay, so let's have a look. For question 4, the first part is you have to compare the acidities of the ethanol and phenol compared to that of water. So this is similar to the one that you have in your notes. Okay. For part B, there is this box is for the conditions should a reaction happens. If there is a special condition, sorry, excuse me. Okay, so for part B, this first reaction is sodium, reaction of sodium with phenol. Is there any reaction that will happen? So you will write down the products here. Conditions, if any. Okay, for the second reaction, this one is reaction with sodium hydroxide and phenol. Again, if there is a product, write down the product, and if there is a condition, a special condition needed, then you write down the conditions. Otherwise, you would just say no special conditions. Like if the reaction occurs at room temperature, there's no special conditions. The third reaction is the reaction of a phenol with an ethanoic acid, CH3COOH. And the last one is the reaction of phenol with bromine. Okay. Next question is question 5. There are a few things that I want to point out here. In phenol, there is delocalization. So there's a hint that the lone pair of oxygen is being delocalized into the ring. In a cyclohexanol, there's no delocalization. Therefore, the only functional group that you have is alkanes and alcohol. Okay, as for the other, you have a phenol. Okay, so phenol is already, so you have both the phenol and the arene or the benzene functional group in that structure. Okay, so explain why these compounds are more soluble in water than their parent hydrocarbon cyclohexane. So that means you have to compare cyclohexanol versus cyclohexane, or they're both the same, sort of more or less the same explanation. Phenol versus benzene. So the hint there is the OH group. Okay, so solubility, you have to talk about if there is an interaction with water. Okay, explain why phenol is more acidic than cyclohexanol. So when it comes to acidity, you have to talk about one of the few factors, the stability of the ion, how easy it is to break the OH bond to release the hydrogen ions into the aqueous solution, or which side of the equilibrium is being favored in dissociation. Okay. So that's a little bit of wordy answers. Next, for each of the following reagents, draw the structural formula of the product. Okay. The structural formula for phenol, sorry, for benzene, you would use, like, for example, C6H5 something. Okay, H5 dot 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 dot. If you want to draw it out, it's also fine. Okay. So again, you have to go through these different reagents, whether or not they will react with this product, taking into account of the functional groups that are present in each of the compound. So I will not talk much about the first two reagents, which is sodium, the first three actually, sodium hydroxide, and bromine. Okay, so remember this reagent, the condition is not mentioned, right? So that means it happens at room temperature with no catalyst or whatsoever. Okay, so that's especially important for bromine, because as you know that bromine can react with alkanes, bromine can react with alkenes, and bromine can react with benzene and phenol. Okay, but under different conditions. With alkanes, you need UV light. With alkenes, you don't need anything. With benzene, you need a halogen carrier, which is aluminum bromide. With phenol, you don't need anything. Okay, so in this case, there is no special condition. Okay, bromine on its own, will it react with cyclohexanol? Will it react with phenol? So you have to refer back to your notes, right? If there is no condition mentioned, that means there is no other condition apart from aqueous bromine on its own. Iodine plus sodium hydroxide is your iodoform reaction from AS. Okay, an excess of acidified dichromate. So dichromate is actually an oxidizing agent. So you have to look at each of these compound. Will cyclohexanol be oxidized? Will phenol be oxidized? Okay. Choose one of the above 5 reagents that could be used to distinguish between cyclohexanol and phenol. Describe the observations you made. Okay, so when you want to distinguish between two compounds, you have to choose a reaction that gives positive tests for one, either positive test with phenol, negative with cyclohexanol, or vice versa. Okay, positive test with one, negative with the other. Okay, you do not want to choose a reagent that gives a positive test for both cyclohexanol and phenol. Otherwise, you wouldn't be able to differentiate. Okay, because if both of the compounds give you positive tests, a positive test means a reaction that can happen, that can be observed. Okay, so you choose a test that is positive with one and negative with the other. Okay. Question 6. So basically what happens in this first route is you go from an alcohol to a haloalkane and then to an amine. Okay. Suggest reagents and conditions for reaction 1. So you go from alcohol to haloalkane. So this is your AS notes. Refer to alcohol AS. Okay. Reaction 2, halogenalkanes to amine, same thing. Haloalkane, refer to your notes, haloalkane AS. Okay. What do you need to convert your halogenoalkanes into an amine? So the hint there is NH2. What type of reaction is reaction 2? Again, refer to your notes, same thing. Suggest a reason why chlorobenzene is much less reactive than 1-chlorohexane. Okay, so this one you may not know it yet. Okay, but I will give you the answer. In chlorobenzene, the lone pair on chlorine is delocalized into the ring, just like oxygen, okay, into the ring. Therefore, CCl bond is strong. Okay, or is difficult to break. I would say it's difficult to break. The carbon chlorine bond in halogen alkane is much easier to break. That's why, in chlorohexane is much easier to break. That's why that compound is more reactive. Okay, suggest a reagent that could be used to distinguish phenylamine and hexalamine. So this is phenylamine versus hexalamine. Okay. Okay, so since you haven't done phenylamine yet, I'm just going to give you the answer for this part. Reagents and conditions, you would use bromine aqueous, or we call this a bromine water. Okay, so this bromine water can react with phenylamine, but not your hexalamine. Okay, so phenylamine, when there is reaction, obviously your bromine water would go from brown to colorless. Okay, so phenylamine decolorizes bromine water, and hexalamine does not. Okay, another observation would also be phenylamine would produce what precipitate. Okay, so this is a reaction that we haven't looked at, but we will in the next two topics. Okay, the one after carboxylic acid. So for hexalamine, it will not react with bromine water at room condition. The last one is question 7. Okay, describe a test that would distinguish phenol from compound A. So I'm just gonna draw a phenol. I mean, we already know how a phenol looks like. Okay, so in a phenol, there's obviously the phenol, which is including benzene functional group. Here, in compound A, we also have benzene functional group and a primary alcohol. Okay, so you need to find a test or a reaction that is, again, same thing, positive in one, negative in the other. Okay, so you find a reaction that can only happen in alcohol but does not happen in phenol, right? So reagents, observations with phenol and observations with compound A. The observations need to be different in these two compounds. If they're the same, then there's you wouldn't be, hold on, I just realized that the screen is not, yeah. Okay, so positive in one and negative in the other. The observations need to differ with these two compounds. I will just bring you back to the previous question after you're done with this. Okay, just pause this page if you need to copy this down. But basically, this is the answer for part C. Okay, so again, please pause this page if you need to copy this down, right? Okay, so that is all for today. Assalamu alaikum wa rahmatullahi wa barakatuh. Thank you, class.